Right, so we're going to have a talk about ratio today. So ratio just means how one quantity, so how one thing, one quantity relates to another quantity. How one quantity relates to another. One easy example, the simplest example I could give you, is how we would have red blobs and let's go for blue blobs. Okay, so if we want to represent the ratio of red blobs to blue blobs, we have to stick it in that order. So if we want the ratio of red to blue, all we'd have is 4 red blobs to 3 blue blobs. Okay, if we wanted the ratio of blue to red, it'd just be the other way round. Make sure that when you are reading a question, you are using the ratio in the correct order. Okay, so that's a 2-part ratio. What you could also have is a 3-part ratio. Okay, this can happen. Or more parts, actually. You can have as many parts as you want. So let's say we've got green. Oops. Let's say we got green, 2 green. Let's say that they're sweets. We got pink ones. I don't know what flavour they'd be. Raspberry, maybe. And let's say that we have brown as well. Let's say that they're chocolate or something. If we were wanting to write the ratio of brown to pink to green, so brown to pink to green. Remember, these were the brown ones. So there's 7 brown, the pink is 5, and the green is just 2 of them. Okay, that's just what ratio means. Another example would be if I had a classroom of people, if I were to separate you into your houses, so let's say that we're using Ormond, Macmillan and Tuckwell. If I split you into that, I just count the amount of Macmillan, amount of Ormond, amount of Tuckwell, and that'll be our ratio, the amount of people there. Now, if we have a ratio that's something like this, let's say we got 6 on one side, and we've got 4 on the other, 6 to 4. That's one way that we can represent the ratio, but we can represent it in a simpler form, okay? Because this means for every 6 of these people, let's call them M's, for every 6 M's, we're going to have 4 F's. Would be useful if my computer pen actually worked. So these were our M's, these were our F's. So the ratio for every 6 M's, there are 4 F's. If we simplify that exactly like we would a fraction, well, these are both in the 2 times table. If we divide them both by 2, then we're going to get 3 to 2. So for every 3 M's, there are 2 F's. Okay, so for every 3 M's, there are 2 F's. That makes sense, doesn't it? Because look, we've got 2 lots of 3 M's, 2 lots of 2 F's. Okay, so that's fully simplified. Okay, so simplifying a ratio, we just recognise what times tables they're in. So if we were given the ratio 10 to 25, you guys can probably recognise, have a think for a second, that yes, they are in the 5 times table. So if we were to divide all of this by 5, we would get 2 to 5. Okay, so that's today's, just an introduction to ratio. Next lesson, you'll be simplifying. You'll be practicing your simplifying with 3-part ratios as well. I'll give you Mrs. Delahanty's video on that because she's already done one, so I don't have to. Okay, so hope that was useful. Thank you very much. See you next time.